So for the graphs of tangent and cotangent, we have to remember where the tangent is undefined. So what's a radian value where the tangent is undefined? Pi over 2 is correct. And so like I said, you can think of this visually. So remember, when you calculate tangent, it's y divided by x. So that means you're looking for a place where the x coordinate is what? Yep, where the x coordinate is 0. So that's going to occur here at 0, 1, and here at 0, negative 1. So like you guys said, it's at pi over 2 at the top. And then if you went to this place, do you guys see how it's pi radians apart? We can write that as an equation, which we started doing when we were talking about intercepts and maxima and minima. So the tangent function is undefined if you have pi over 2 plus pi times n. Okay, so pi over 2 is where you would start. Remember, n is any integer. So if it was 1, you'd add 1, you'd get to 3 pi over 2. If you add another pi, you'd be back up here. Okay, and it would be any rotation. For the cotangent, that's when you do x divided by y. So the cotangent is undefined where? At pi, yep, that's one of your places, and 0. Okay, so this would be pi, this one would be 0, and yep, and technically 2 pi, that would be the rotation. So again, you are that pi radians away. So if you did 0 plus pi n, it would just be pi n. So they'll simplify it and just say the pi n instead of the 0 plus. Okay, now because they are undefined, these are going to be represented by something that we have graphed before. These are represented by vertical asymptotes. So the graphs of tangent and cotangent are going to have asymptotes. You might remember that asymptotes are going to be dashed on your graph. So we are going to have to do that. And then let's look at the graphs. They're right here. So you have tangent. These look very similar to cubic functions, x to the third. And with sine and cosine, you had a maximum and a minimum. But these are going up to infinity and down to negative infinity. And what that means is you are going to have no amplitude, or the amplitude is undefined. So because there's no max or min, the amplitude is undefined. Okay, the tangent and the cotangent, they have no max or min values. Okay, so your amplitude is going to be undefined. All right, now the period's a little bit different from sine and cosine. So these are the two parent functions. It is pi and pi. Remember, sine and cosine were 2 pi. Okay, and if you look at the tangent from left to right, it's going to go up. And then for cotangent, it's going to go down from left to right. So I usually say from L to R. Okay, so for the tangent from left to right, it goes up. Here from left to right, it goes down. Okay, and sometimes I'll accidentally do the tangent and I'll have to remember, oops, it goes the other way. So remind me when we get there. Now to make sure it's going the right way. Now these are reflections of each other, which means if you had the negative tangent, it would look like cotangent. And if you had a negative in front of cotangent, it would look like tangent. Okay, so the domain, they're just telling you it can't be at a place where it's undefined. That's okay. And then y, the range, negative infinity to infinity, because we have those arrows in both directions, so we have an undefined amplitude. All right, this is asking you for the x-intercepts of tangent. Where are the x-intercepts of tangent? So let's mark them down. We have negative pi, we have 0, we have pi. So negative pi, 0, pi. So what we're going to do is we are going to write an equation for that. Okay, so normally I'll say like it starts at, and I'll give the first one that's positive. So we can say it starts at 0 and repeats every how many units. So we just have to find the distance in between. So from 0 to pi and from negative pi to 0, what's the distance in between those? Pi. So from there, we can write an equation. Okay, so if it starts at 0 and repeats every pi units, we'd say 0 plus pi n, or just pi n. These are where the x-intercepts of the tangent are going to be. And remember, we use n as an integer. So what this means is if you plug in -1, you get negative pi. That's where you have an x-intercept. If you plug in 0, 0 is where you have an x-intercept. If you plug in 1, you have an x-intercept there. If you plug in 2, 2 pi, okay, and then it just continues. So I want you to try to do the x-intercepts for cotangent. So where are the x-intercepts? List at least 3. I think actually from this one you can list 4. Oh, Silas, will you take that pass with you? Do you want to, All right, so first thing is I want you to put the x-intercepts on your graph like we did before. So I want you to mark off the x-intercepts like we did before up here. Okay, so Royal, give me one of the x-intercepts that you wrote down. So one of them from your graph here. So this is going to be halfway between 0 and negative pi, so that's going to be what? Yep, so negative pi over 2 is one of them. Okay, and then Alex, what's another one?
Pi over 2.
Pi over 2, great. Okay, and then Megan, what's another one? Yep, so you can do negative 3 pi over 2. And then on the opposite side would be positive 3 pi over 2. Okay, great. Okay, and then we are going to come up with the equation for that. So again, think of where you start. Okay, so fill in those 2 blanks. Once you fill them in, see if you can write the equation. Okay, so then Akul, what'd you fill in for this blank here?
Pi over 2.
Yep, and then repeats every pi units. Great, so then this is just going to be pi over 2 plus pi n. Okay, and these are where the x-intercepts occur for the cotangent. All right, now what is not shown on these graphs above are where your vertical asymptotes are. So we marked off where our x-intercepts were. Now we're going to put in the vertical asymptotes. So if you look here, we said pi over 2 plus pi n. So if this is 0 and this is pi, pi over 2 would be right in between there. Remember, it's a dashed line. And then if I go pi more units, I'm going to be right here. And then that pattern's going to continue. So remember, you want those dashes. Okay, we don't want the solid lines. Okay, and then here we said the cotangent function is undefined at pi n. That means your first one is at 0. So the first asymptote, and then it occurs every pi units. Okay, so these equations are for when you are plugging in values for n, you're plugging in integers. Remember that an integer is just a positive or negative whole number. And then because this is our first time learning this, those are the two things we're going to focus on. We're going to focus on x-intercepts, and we're going to focus on the asymptotes. We aren't going to focus as much on the points. You will get more of that in trig or pre-calc. But we're going to let those be our guide today, okay? All right, so you have a few information boxes below about the transformations. So we have one for tangent, we have one for cotangent. We are going to be using these to help us with where to put the asymptotes. Okay, and you might also see your equation for the period is in there. So it says the period is pi over b, and it's the absolute value. You are going to use the absolute value, but you'll commonly see it like this. The period is pi divided by b. So whereas sine and cosine repeated every 2 pi units, tangent and cotangent repeat every pi units, and that's why we're going to use that. And it's the same for both. What is not the same for both is the asymptote equation, and you do need to use, again, this value of b. So whenever you are writing out your equation for the asymptote, it's going to be x equals because it is a line, but you do pi divided by 2b plus pi n divided by b. And then we're going to find these by plugging in values for n, because it says where n is an integer. You're probably going to like the cotangent one a little better just because it's a little simpler there. So for the cotangent, it's x equals pi n over b. And that's where those asymptotes are going to be. Okay, now you might notice this equation comes from what we wrote down above. See how we said the cotangent is undefined when it's pi n? This is just pi n divided by b. Okay, so that's because you're going to have a different period. You're going to have a transformation. And then we said pi over 2 plus pi n. So it's pi over 2 times b plus pi n over b. So you just have to take into account, is there going to be some type of transformation? And then they don't give you an equation to find the x-intercept, so I'm just going to give you one that you can use. You can always use the x-intercepts by taking one of them. Usually I do the first positive one. So take the first positive or 0 x-intercept, and then you're going to add the period times n. So whatever your period is, these two had a period of pi, but that's going to change for some of these. And then you're going to multiply that by n. Okay, so we're going to graph one tangent together and one cotangent, and then I'm going to let you practice. All right, so in example 2, it says using the tangent or the cotangent as a guide, graph the following functions. Identify the period, the x-intercepts, and the asymptotes. Okay, so the first step to doing this is finding the period, which we have done many times before. The only difference is now we do pi over b. All right, and then what's going to be our value for b in this equation? Do you remember where your b value is? Yep, so it's always in front of the x. So if b is 1/3, okay, if I have pi divided by 1/3, what's that going to be? 3 pi, because remember you multiply by the reciprocal. Okay, so your period is going to be 3 pi. Okay, so after you find the period, then you are going to do the x-intercepts. And we have to change one thing in here with the wording. It's small. Okay, so on the graph of f of x, okay, which is the tangent, we know that an x-intercept occurs at 0. Okay, so I'm just using what we wrote down here. So see on the graph of tangent, we're at 0. Okay, and then for this graph, the period is 3 pi. The x-intercepts are going to occur at, so remember, our equation for the x-intercept is just the x-intercept plus the period times n. Okay, so if I do this, if I plug in 0 plus 3 pi n, what does that make? 3 pi n. Okay, that's where your x-intercepts are going to occur. Okay, where n is an integer. Okay, so you take your x-intercept, take the period, you do the x-intercept plus the period times n, and then we're just going to change this to where are 3 intercepts on the graph of f of x. Okay, so f of x, meaning it equals the tangent of x. Okay, so the 3 intercepts on that graph, we already wrote those down. So we're just going to go back here. So the x-intercepts for the tangent function are negative pi, 0, and pi. So we're going to write those here, negative pi, 0, and pi. Okay, and then in order to find the x-intercepts of our new graph, we are going to take the x-intercepts of tangent and multiply them by the reciprocal of b. You want to do this so you can always get that b value adjusted. So we're going to do the x-intercepts of the tangent. And then we're going to multiply by the reciprocal of b. Okay, so I found it easiest to list them. So we're always going to take the x-intercepts of the parent function, negative pi, 0, pi. And then we have to apply this, it's a stretch that's happening, it's a horizontal stretch. We do that by multiplying by the reciprocal. So just like here, how we divided by 1/3, when you divide by 1/3, it's the same thing as multiplying by what? Yep, the reciprocal, which would be 3. So the reciprocal of b is 3. Okay, so if b is 1/3, the reciprocal is 3. And then all we have to do here to graph these is multiply straight across. So negative pi times 3 is negative 3 pi. 0 times 3 is 0. Pi times 3, 3 pi. So these are going to be x-intercepts on our graph. So we want the x-intercepts and we want the asymptotes. Those are the two things that we need to graph. And we're always going to do 3 of each so we can see what that pattern is. For the asymptotes, though, you do have a given formula. So we're just going to plug into our formula. Okay, so it says identify the asymptotes. So I put the equation here so you wouldn't have to flip back and forth. See, it's the pi over 2b plus pi n over b. And then what are we going to plug in for b? 1/3. So we have pi over 2b plus pi n over b. Okay, so do you guys think that you can plug that in and then find what your equation is? Think you can simplify the equation? So you don't want a fraction within a fraction. So think about how you are going to simplify that. We're going to use the equation. We're going to simplify that. So where do you guys want to start when you're simplifying? When you have that fraction within a fraction. Where are we going to start with the simplifying? Well, what did we get for the first part? Okay, what did you get for the first part? Yeah, because what's 2 times 1/3? 2 over 3. So if you're dividing by 2/3, isn't that the same thing as multiplying by the reciprocal? Yeah, so it's just going to be x equals pi divided by 2/3 is 3 pi over 2. You just flip this. Okay, that's what's happening. What's happening here? You're multiplying by 3 over 1. So pi n times 3, Arnav, what'd you get for that? Yeah, plus 3 pi n. Great. So this is your equation for your asymptotes. Okay, the equation is going to help us generate the asymptotes. Okay, so remember how I keep saying n is an integer, n is an integer. We are going to be plugging in integers for n. Okay, so to find the asymptotes on the graph, we are going to plug in n equals -1, 0, and 1. Can you guys think about why I'm choosing those integers in particular? I mean, one, they're probably going to be the easiest to compute, right? But look at your graph, okay? If you plug in 0, you're going to be closer to the axis. So the -1, 1, and 0 are going to be the ones that are for sure going to be on your graph. If I plugged in 5, when I'm graphing, it might be out over here. Okay, so that's not going to be helpful. So -1, 0, and 1, those are going to be the ones closest to the origin. Okay, so those are going to be the most useful to us. So if we plug those in, okay, if we plug in n is -1, and eventually you're going to get really good at this where sometimes you might not even need to like show the plug-in, but it's x equals 3 pi over 2 plus 3 pi times -1. And you guys have added radians together before. You guys did that on your first quiz in chapter 11, right? So if you have 3 pi over 2 minus 3 pi, yeah, you can get the common denominator times 2 times 2. So it'd be 3 pi minus 6 pi over 2. And like I said, some of you are going to be able to do that part in your head. Some of you are going to want to write it down. Do what makes the most sense for you and what you can do with the least amount of errors. For me, I like seeing this, like I like seeing the multiply. 3 pi minus 6 pi, -3 pi. Okay, -3 pi over 2, that is going to be one of our asymptotes. The 0 is always my favorite to plug in because if you are plugging in 0, what are you going to get for this? If you plug in 0 for n, what do you get here? Nothing here, and then it'd just be 3 pi over 2. Yes. Okay, so like I said, you don't even have to show your work for that. You just have to write down what it is if it's the 0. Okay, and then for the n equals 1, you have x equals 3 pi over 2 plus 3 pi times 1. All right, so see if you can find what that is, and then we're going to organize our information together just so we can look at it in one place. All right, and then Caleb, when you got this, let me know what you got. For when you plugged in n equals 1, what did you get for your last value here? Because if you multiply by 2 over 2, right, this is 3 pi plus 6 pi over 2. Okay, so when you are graphing, you need to take a few things into account. You have to take into account the x-intercepts, -3 pi, 0, and 3 pi. You have to take into account the asymptotes, which are -3 pi over 2, 3 pi over 2, and 9 pi over 2. Okay, based on these values, can you guys tell me what you think a good scale would be? Pi over 2, because these you have at the pi over 2s, and when you count by pi over 2s, you're going to see that some of them are going to simplify. So just like we did before, we're going to label on the bottom, okay? So if this is 1 pi over 2, what's 2 pi over 2? Pi. So can you see every other one is going to be a pi? So 1 pi over 2, 2 pi over 2. I want to label the 3 pi over 2 because I can see I have something there. 4 pi over 2 is 2 pi. 5 pi over 2. 6 pi over 2 is what? 6 pi over 2 is what? 3 pi. So 7 pi over 2, 8 pi over 2, 9 pi over 2. Just maybe. And then, like I said, notice every other one is a pi. So on this side, just do negative pi, -2 pi, -3 pi. Okay? And then when you're graphing this, You can start with the x-intercept or you can start with the asymptotes. I like to start with the asymptotes. And then you're going to take a marker or a highlighter. So at 3 pi over 2, we're going to make a dashed line. So do not highlight a solid line. I think when we did these the first time, a few people went rogue and just did the straight highlight. But you do need to do the dashed line. Okay, and then the reason why we're doing 3 is so we can identify our pattern and make sure it is symmetric on both sides. Okay, and then you have negative 3 pi over 2, which is 1, 2, 3. So 1, 2, 3. And then if you did this correctly, you should have the same amount of spaces in between and you continue the pattern. So 1, 2, 3, 4, 5, 6, asymptote. 1, 2, 3, 4, 5, 6, asymptote. 1, 2, 3, 4, 5, 6. It is on the last one, so we do have to put it on there. So make sure you have your asymptote on the end. So you're going to span your graph no matter what. Then we're going to put in the asymptotes. Okay, so your asymptotes, we already did those. Now we're going to put in your x-intercepts. Your x-intercepts, you have it 0, 3 pi, negative 3 pi. Again, these should be symmetric. So 1, 2, 3, x-intercept. Okay, and when I say 1, 2, 3, I mean from the asymptote there. And then they are still 6 units apart. So 1, 2, 3, 4, 5, 6, x-intercept. 6, x-intercept. All right, now I want you to watch me first. Some of you may have already squiggled, and we're not squiggling. We're paraboling. Okay, so your tangent graph, I know it does look like a little squiggle there, but this is how you make it. I'm going to show it to you here. This is tangent. So once you have your intercept, you do half a parabola going up to the right, and then half of a parabola going down. What decides how narrow or how wide it is are the asymptotes. So these are pretty wide. So when you do this, you need it to follow where the asymptotes are going to go. So I want you to put half of a parabola here. And then we're going to do half of a parabola here. Okay, this is wider because you have a horizontal stretch happening. So we're doing half of a parabola up, half of a parabola down. Half of a parabola up, half of a parabola down. So those are the only things I want you to focus on. I want you to focus on it following the asymptotes. Okay, and your x-intercepts, so half of a parabola. And this is your tangent. So we did go the right direction. Okay, when you list these, this is for your graph, okay? When you are writing equations, you are going to have to know the x-intercepts occur at the 3 pi n. That's what we wrote down above. And we have to know the equation for the asymptotes. Asymptotes occur at, okay, asymptotes occur at x equals 3 pi over 2 plus 3 pi n. Okay, so somewhere in your work you should have both of these things. We use these to graph. Okay, this is going to be something that you're going to be asked to identify. Okay, so I'm going to be looking for both of those in your work there. All right, let's try the cotangent now. All right, so for the cotangent, go ahead and identify the period. You guys know how to do that, so go ahead and find it. All right, and then River, when you got your period, just let me know what you got. Great, pi over 3 is correct. Okay, so remember this is where your b value is, so your b value is 3. So now we are ready to do the x-intercepts. So we're going to look again at the original graph on the front. So on the graph of the cotangent, the x-intercept occurs at, we're going to take the first positive one. So it occurs at pi over 2. Because the period is pi over 3, okay, the x-intercepts are going to occur at pi over 2 plus pi over 3n. So that is the equation that says where they occur. Okay, so you do need to write down the equation. And then we are also going to be finding those values. Okay, and then we're going to do 3 intercepts on the graph of the cotangent. F of x equals the cotangent. We're only going to do 3, so let's start with negative pi over 2, and then do the pi over 2 and 3 pi over 2. We wrote down 4 on the front. Okay, so we want to make sure that we are taking those values and we are multiplying them by the reciprocal of b. Okay, so we have the x-intercepts of cotangent. So negative pi over 2, pi over 2, 3 pi over 2. We're going to multiply by the reciprocal of b. All right, so if b is 3, what's our reciprocal going to be? 1/3. So we're going to multiply everything by 1/3. So we're just multiplying a fraction by a fraction here. So I want you guys to multiply straight across, reduce if you need to, and then see if you can do the asymptote equation after you found those. All right, so if we multiply across, negative pi over what? What did you guys get for your denominator? 6. So then you have pi over 6. Now here you had 3 pi over 6, which reduces to pi over 2. Okay, so these are going to be the x-intercepts that we're going to graph. Okay, so we're going to have to reference those again. Now we're going to do the asymptote, so we're going to use our equation. So your equation is right here, pi n over b. So you can look at that and you can use that, but you aren't going to have to memorize that, okay? So look at it, use it, love it. So your b value is going to be 3. So these are where your x-intercepts are, or your asymptotes are, sorry. Okay, so x equals pi n over 3. Now this is where you're going to plug in the values of n. So you're going to plug in n equals -1, n equals 0, and n equals 1. This one is a little simpler than the other one, right? So I'm going to show the work for that, but when you're doing this on your own, this is something you can do with mental math. So it's pi n over 3. So you plug in -1, 0, and 1 for n. And then just go ahead and evaluate. And that's where you're going to put the asymptotes on your graph. So when you're deciding what the scale is, you're looking at the x-intercepts, you're looking at the asymptotes. Hold on, I can't process memory. If you ever get the same values for each, something went wrong because you cannot have those overlap. And then, Blake, will you repeat your question? I couldn't understand. So these are where your x-intercepts are going to be. This is where your asymptotes are going to be. Based on those, let's pick a scale. What do you guys think our scale should be? Pi over 6. Because if you go by pi over 6, aren't you gonna hit the pi over 3s? Yes. Okay, so if you do 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2. I do cluster those sometimes if they're all these important values, and then I tend to like space things out a little bit. Like if 3 spaces is pi over 2, then 3 more spaces I'm going to be at pi. 1, 2, 3, pi over 2, 1, 2, 3, pi, 1, 2, 3, 3 pi over 2. With the equation. So the equation will be, you can use this. Anytime you have cotangent, it's x equals pi n over b. So it is a little bit different than the one that we use for the tangent. Okay, and then once you have that established, now we can plug in, like I said, I like to do the asymptotes first. Use this. Okay, so I'm at 0. So if you're at 0, try to like put that to the side so we can see it where the asymptote is. And again, it's going to be a dashed line. Okay, and what we have going on here is we have a compression, which means we are going to have a lot more cycles here. So 1, 2. So every 2 spaces, there's going to be an asymptote. So we're going to continue that pattern. Every 2 spaces, we're going to have a dashed line. Okay, and then when you are ready, you can put in the intercepts. And if you did this correctly, you'll see that they are in between there. And yep, we're even putting one there. We are going to do, sometimes you have half of a cycle. We'll put that in. And then I am reminding you as well as myself that cotangent, you go up to the left and then down to the right. That's your cotangent. So this one is going to be narrower. You are going to follow the asymptote. It should never cross it. Okay, but you are going to have a narrower graph here. And that's what we want. So I'm still doing my parabola. My parabola up to the left, down to the right, up to the left, down to the right. Okay, we don't have to rush through these because we're going to have time in class to work on them. Okay, I will give you a graph sheet as well as a worksheet, and you can decide where you would like to put your work on there. So before you even get to the graph, you're doing this preliminary work, finding the x-intercepts, finding the asymptotes there. So don't forget this little bit of the cycle, this little bit of the cycle. And then we have our equation. So the x-intercepts, we said we're at pi over 2 plus pi over 3n. And then the asymptotes are going to occur at pi n over 3. And then just make sure that you do have that equal to the x there. Right? You don't have to repeat this twice. I am just doing that so when we get to the graph, we can look at all of those together. Okay?